To prepare for the Indiana Master Electrician exam, firstly, utilize Mike Holt's preparation materials. Mike Holt study guides and practice tests are valuable resources. Secondly, familiarize yourself with the National Electrical Code 2005 codebook. The test heavily emphasizes the National Electrical Code 2005 code, so it's crucial to thoroughly study this document. Thirdly, read the book from front to back. The exam covers a wide range of electrical concepts. Reading the entire code book from cover to cover will provide a comprehensive understanding. Fourthly, focus on the code. The exam primarily tests knowledge of the electrical code. Memorizing specific article numbers and code sections will be beneficial. Fifthly, practice with mock exams. Take multiple practice exams to simulate the actual test experience and identify areas for improvement. Sixthly, understand the Indiana Electrical Code amendments. Indiana has adopted amendments to the National Electrical Code, so be aware of these additional requirements. Seventhly, study the diagrams. The exam includes many diagrams and schematics. Practice interpreting and analyzing these representations. Eighthly, stay up to date with industry knowledge. Keep abreast of any changes or updates to the electrical industry, as they may be included in the exam. The Master Electrician exam is challenging, but with proper preparation and dedication, it is achievable. Specific areas to focus on within the National Electrical Code 2005 include, but are not limited to, Article 210, which covers branch circuits. Understand the requirements for general-purpose circuits, appliance circuits, and individual branch circuits. Pay close attention to conductor sizing, overcurrent protection, and outlet requirements. Next, Article 220, which addresses branch circuit, feeder, and service calculations. Learn how to calculate the minimum load requirements for various occupancies and equipment. Understand the demand factors that can be applied to reduce the calculated load. Article 230 covers services. Know the requirements for service conductors, service equipment, and grounding. Understand the different types of service configurations and their associated requirements. Then Article 250 discusses grounding and bonding. Master the requirements for grounding electrode systems, equipment, grounding conductors, and bonding of metal parts. Understand the purpose of grounding and bonding and how they contribute to electrical safety. Article 300 covers wiring methods. Be familiar with the different types of wiring methods permitted by the National Electrical Code, such as rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable. Understand the installation requirements for each wiring method. Article 310 discusses conductors for general wiring. Learn how to select the appropriate conductor size based on the ampacity requirements and the ambient temperature. Understand the different types of conductor insulation and their applications. Article 400 covers flexible cords and cables. Know the permitted uses and limitations of flexible cords and cables. Understand the requirements for strain relief and overcurrent protection. Article 430 discusses motors, motor circuits, and controllers. Be familiar with the requirements for motor circuit conductors, overcurrent protection, and motor controllers. Understand the different types of motor starters and their applications. Article 450 covers transformers. Learn the requirements for transformer installations, including overcurrent protection, grounding, and ventilation. Understand the different types of transformers and their applications. Article 500 and subsequent articles address hazardous locations. Be familiar with the requirements for electrical equipment and wiring in hazardous locations, such as those containing flammable gases or dusts. Understand the different classes and divisions of hazardous locations and the specific requirements for each. Other key areas to study are overcurrent protection. Understand the different types of overcurrent devices, such as circuit breakers and fuses, and their applications. Know how to select the appropriate overcurrent device for a given circuit. Also, be sure to study boxes and enclosures. Be familiar with the requirements for electrical boxes and enclosures, including their size, construction, and installation. Understand the different types of boxes and enclosures and their applications. Grounding electrode system, which includes understanding the requirements for grounding electrodes such as ground rods, ground plates, and metal water pipes. Know how to properly install and connect grounding electrodes. Bonding, which includes understanding the requirements for bonding metal parts such as metal conduits, metal enclosures, and metal piping systems. Know how to properly bond these metal parts together to create an effective ground fault current path. Wiring methods, which includes being familiar with the different types of wiring methods permitted by the National Electrical Code, such as rigid metal conduit, electrical metallic tubing, and non-metallic sheaths cable. Understand the installation requirements for each wiring method. Conductor ampacity. Learn how to determine the ampacity of conductors based on their size, insulation type, and ambient temperature. Understand the ampacity correction and adjustment factors that must be applied in certain situations. Voltage drop. Understand the concept of voltage drop and how to calculate the voltage drop in a circuit. Know the recommended voltage drop limits for different types of circuits. Motor calculations, which include being familiar with the requirements for motor circuit conductors, overcurrent protection, and motor controllers. Understand how to calculate the full load current, branch circuit conductor size, and overcurrent protection for motors. Transformer calculations, which includes learning the requirements for transformer installations, including overcurrent protection, grounding, and ventilation. Understand how to calculate the primary and secondary currents, voltage, and kilovolt-ampere rating of transformers. Hazardous locations, which includes being familiar with the requirements for electrical equipment and wiring in hazardous locations such as those containing flammable gases or dusts. Understand the different classes and divisions of hazardous locations and the specific requirements for each. Special occupancies, which includes being familiar with the requirements for electrical installations in special occupancies such as healthcare facilities, swimming pools, and marinas. Understand the unique electrical hazards associated with these occupancies and the specific requirements for mitigating those hazards. Also, understand equipment listing and labeling. Understand the importance of equipment listing and labeling and how to identify listed and labeled equipment. Know the role of testing laboratories, such as underwriters' laboratories, in ensuring the safety of electrical equipment. Using Mike Holt's materials. Take advantage of Mike Holt study guides, practice exams, and online resources. These materials provide comprehensive coverage of the National Electrical Code and help you prepare for the exam. Taking practice exams. Take as many practice exams as possible to simulate the actual test experience and identify areas where you need to improve. Review the questions you missed and understand why you got them wrong. Reviewing the National Electrical Code Commentary. Read the National Electrical Code Commentary to gain a deeper understanding of the intent behind the code requirements. The commentary provides explanations and examples that can help you apply the code in real-world situations. Staying up to date on code changes. The National Electrical Code is updated every 3 years, so it's important to stay up to date on the latest changes. Subscribe to industry publications and attend continuing education courses to stay informed. Understanding the Indiana Amendments. Be sure to review the Indiana Amendments to the National Electrical Code and understand how they differ from the base code. The Indiana Amendments may include additional requirements or modifications to existing requirements. Managing test anxiety. Test anxiety can negatively impact your performance on the exam. Practice relaxation techniques, such as deep breathing and visualization to help manage your anxiety. Arrive at the testing center early so you have plenty of time to get settled in. Reading each question carefully. Read each question carefully and make sure you understand what is being asked before you attempt to answer it. Pay attention to keywords and phrases that may provide clues to the correct answer. Eliminating incorrect answers. If you are not sure of the correct answer, try to eliminate the incorrect answers. This will increase your chances of selecting the correct answer. Guessing strategically. If you're still not sure of the correct answer after eliminating the incorrect answers, make an educated guess. Don't leave any questions unanswered. Reviewing your answers. If you have time, review your answers before submitting the exam. Make sure you haven't made any careless errors. The most recent version of the National Electrical Code is the 2023 edition. However, for the Indiana Master Electrician exam, it is important to confirm with the Indiana State Board of Electrical Contractors what edition of the National Electrical Code the exam will be based on, as it may differ. As electrical systems evolve, new articles and revisions are incorporated into the National Electrical Code to address these advancements. For instance, there might be new sections on energy storage systems, electric vehicle charging equipment, or updates to requirements for renewable energy sources like solar photovoltaic systems. These changes reflect the industry's shift towards sustainability and energy efficiency. There have been significant revisions over time. Grounding and bonding requirements have been updated to ensure electrical safety and reduce the risk of electrical shock. Article 250 has undergone numerous revisions to address new grounding technologies and to clarify existing requirements. Overcurrent protection. Article 240 has been revised to address new types of overcurrent devices, such as arc fault circuit interrupters and ground fault circuit interrupters. These devices provide enhanced protection against electrical hazards. Wiring methods. Chapter 3 has been revised to incorporate new wiring methods and to update the requirements for existing wiring methods. These changes reflect advancements in wiring technology and materials. Special occupancies. Articles 500 through 590 have been revised to address the unique electrical hazards associated with special occupancies such as healthcare facilities, data centers, and industrial facilities. These changes ensure that electrical systems in these occupancies are designed and installed to minimize the risk of electrical hazards. Energy efficiency. The National Electrical Code has been revised to promote energy efficiency in electrical systems. These changes include requirements for lighting controls, motor efficiency, and power factor correction. Renewable energy. Article 690 has been revised to address the growing use of renewable energy sources, such as solar photovoltaic systems. These changes provide guidance on the safe and effective installation of renewable energy systems. Smart homes. The National Electrical Code has been revised to address the increasing popularity of smart home technologies. These changes include requirements for home automation systems, voice-controlled devices, and smart appliances. Electric vehicles. Article 625 has been revised to address the growing use of electric vehicles. These changes provide guidance on the safe and effective installation of electric vehicle charging equipment. Energy storage. Article 706 has been added to address energy storage systems such as batteries and flywheels. This new article provides requirements for the safe and effective installation of energy storage systems. These revisions reflect the ever-changing landscape of the electrical industry and the National Electrical Code's commitment to ensuring electrical safety and promoting innovation. The Indiana amendments to the National Electrical Code can be found on the Indiana Professional Licensing Agency website. These amendments typically address specific local conditions or requirements that are not covered by the National Electrical Code. For instance, there may be amendments related to wiring methods in certain types of buildings, or amendments related to the installation of electrical equipment in specific environments. The Indiana amendments are typically adopted by the Indiana Electrical Code Technical Advisory Committee and are incorporated into the Indiana Electrical Code. Electrical plans examiners use the Indiana Electrical Code, including the Indiana amendments, to review electrical plans for new construction and renovation projects. The examiners ensure that the electrical plans comply with all applicable codes and regulations. Electrical inspectors use the Indiana Electrical Code, including the Indiana amendments, to inspect electrical installations for new construction and renovation projects. The inspectors ensure that the electrical installations comply with all applicable codes and regulations. Some examples of Indiana amendments to the National Electrical Code include amendments related to the installation of ground fault circuit interrupters, amendments related to the wiring of swimming pools, and amendments related to the installation of solar or photovoltaic systems. These amendments are designed to enhance electrical safety and to address specific local conditions. In conclusion, preparing for the Indiana Master Electrician exam requires a comprehensive understanding of the National Electrical Code, the Indiana amendments to the National Electrical Code, and electrical theory and practice. By following the tips outlined above, you can increase your chances of success on the exam. Remember to stay calm, read each question carefully, and manage your time effectively. With proper preparation and dedication, you can achieve your goal of becoming a licensed master electrician in Indiana. Remember to check with the Indiana Professional Licensing Agency for the most current and accurate information regarding the exam.